Hi guys, I'm Cathy and I'm from NFTScan Marketing. Today I'm here to talk about how NFTScan provides professional data services based on TiDB database. And firstly, let's quickly know about what is NFTScan. NFTScan is a professional multi-channel NFT data infrastructure. At present, it is the largest NFT data server in Asia. NFTScan aims to provide efficient and concise NFT search and query services for Web3 users, as well as professional NFT data services for the new generation of financial technology companies. As of November 2022, NFTScan has supported 9 blockchain networks, which are Ethereum, Solana, BNB, Polygon, Avalanche, Arbitrum, Optimism, Moonbeam, and Platon. More blockchain networks is coming in continuous integration. Based on the current 9 blockchain networks, NFTScan has parsed and collected the online data of more than 600,000 NFT collections. Now it has the largest NFT asset database in the whole network. Based on this database, NFTScan has developed 2 products. First is NFTScan Multi-Chain Explorer, which provides users with search and query services of NFT wallet address and NFT contract. Users can query the on-chain data of any NFT assets and any NFT collection, as well as social profile information. In addition to the NFTScan Multi-Chain API, Multi-Chain NFT Explorer, the NFTScan team also launched the Open API platform in order to provide professional NFT data API service for blockchain developers. NFTScan currently serves more than 100 blockchain projects, including ZipPal, Mask Network, mToken, CyberConnect, PingCAP, Numbers Protocol, Cocoon, Slowmist, OneKey, etc., and other well-known blockchain projects, providing them with professional NFT data service. Based on NFTScan Open API, every blockchain developer can quickly build their own products and protocols. As of November 2022, NFTScan has collected 656,080 NFT contracts, over 100 million NFT assets, and about 1.3 billion NFT records, and over 62 million wallet addresses holding NFT assets, plus over 1,000 NFT marketplace contracts have been added into NFTScan. NFTScan currently has the largest NFT database in the whole network. Among the current 9 blockchains supported by NFTScan, an average of 2,000 NFT collections and 1.5 million NFT assets are daily increased. The NFTScan team plans to support another 10 to 12 blockchain networks in 2023, covering the leading 20 blockchain networks with NFT ecosystem. It is estimated that in 2023, the number of daily increased NFT collections on-chain will be around 5,000, and the number of NFT assets will be around 5 to 6 million. The data scale will be 3 to 5 times than this year. So with the explosion of the NFT space in the latest 2 years, NFT now becomes the most influential crypto assets in the crypto industry, since NFT assets carry additional metadata information. Its value and the scale of data is much larger than FT assets, and the high scalability of NFT assets allows us to use NFTs to encapsulate and disseminate any valuable information, improving its freedom of transaction and dissemination. The NFTScan team firmly believes that with the continuous development of NFT space, the logical complexity of NFT assets will keep rising, coming with an appearance and wide exploit of innovative value. What's more, the NFT data will also keep growing explosively on-chain. The NFTScan team will continue to focus on the NFT data, manage to do a good job in the analysis and the standardization of NFT on-chain data, constantly providing professional NFT data services for hundreds of millions of Web3 users and developers in the future. So here comes the mainly 5 types of NFTScan customers. First is crypto wallet and NFT marketplace, on-chain data analysis products, NFTFi, SocialFi. All these kind of our customers are using the API services on NFTScan Open API platform. Because of the characteristics of the blockchain industry and the customer's NFT business scenario, the data services provided by NFTScan must be comprehensive, real-time, and efficient. Naturally, there's also a necessity for high concurrency and low latency of API services. Therefore, for the technical architecture of NFTScan, it is very important to choose the most suitable data storage systems that can best meet business needs. So let's talk about why we use TiDB as the core underlying database of the NFTScan application architecture. At the beginning, we chose to use MySQL and Elasticsearch on AWS as our core storage. MySQL stores data for all our applications, including data analysis, data statistics, business data, and customer data. Among them, the transaction records and asset records of NFTs are our core business data. Most of the queries on the business side and the consumer side are carried out around these 2 types. In view of the continuous daily growth of NFT data and the uneven distribution of NFT data from the contract dimension, we have synchronized these 2 types of code data to Elasticsearch in a nearly fulfilled index way to support multi-dimensional NFT data queries with various types, so as to solve the performance and efficiency bottleneck of MySQL in multi-dimensional retrieval of massive data. We have certainly considered the sub-database and sub-table solution based on MySQL, but due to the properties of NFT data distribution and the complexity of data management introduced by it, such solution is not suitable for our storage scenario. There are also some drawbacks in using the storage scheme of MySQL plus Elasticsearch. For MySQL, with the continuous expansion of new blockchain data, we need to add new primary and secondary MySQL clusters to share and balance the use of CPU and memory resources, which brings an increase in spend and maintenance costs. For Elasticsearch, due to the limitation of AWS native cluster configuration, more high configuration data nodes are needed to provide online query services. Therefore, there has always been a problem of high cost and low utilization rate. Additionally, Elasticsearch itself is positioned for search scenarios that would be precision errors of aggregation calculations. So it is not the ideal storage solution. Therefore, we have been looking for a scalable distributed storage database suitable for our application scenarios. After nearly a month of research, we finally decided to use TiDB as our core underlying storage. There are several considerations here. First is that TiDB is compatible with MySQL in terms of transport protocols and SQL syntax fees, which can greatly reduce the learning costs of our research and development team for using the new database. accelerating the migration of storage architectures. The second is that TiDB adopts an architectural model with the separation of compute and storage, and its design mechanism for distributed storage of underlying data, which ensures that the server resources of the database can be elastically scaled according to actual data conditions and changes in read and write traffic, so as to schedule demand and maximize usage efficiency. Third, TiDB's data replication mechanism and various built-in disaster recovery solutions guarantee the high availability of database services. Fourth, as a database of HTAP, TiDB's typeless component meets some of our query requirements based on column storage, bringing great benefits to more data analysis work in the future. Requirements for transactional and analytical database are also directly satisfied by a set of database storage system. Plus, we also built a TiDB cluster for testing, imported some business data, and applied core business queries. The performance was also better than our previous storage solution. Now, NFTScan has completed the work of switching all the underlying storage to TiDB database. As for the TiDB cluster architecture, under the current stable condition of the traffic, we have adopted a deployment mode of 2 TiDB servers, plus 9 TiKV servers, plus 2 typeless servers, spanning 3 available zones in the same region. At present, various applications of NFTScan are running stably on the basis of TiDB. The cluster QPS is about 5,000, and the query duration is about 40 milliseconds on average, with a total of about 6 terabytes business data stored. Next, let's talk about some experience in the process of switching and using TiDB database. During the process of migrating business data, TiDB provides a series of data synchronization tools, such as dumpling tools, which helped us quickly complete the migration of historical data from MySQL to TiDB. Some business data that cannot be directly migrated will be imported into TiDB via the application after the adjustment of the data scheme is completed. In such a process, we also experience excellent support for concurrent writing of large amounts of data provided by TiDB. At the core operation, when parsing NFT data in real time and storing the data, the execution efficiency has increased by about 30% compared with the previous storage plan. At the same time, TiDB's excellent design of online scheme update allows us to perform DDL operations such as changing fields and adding index synchronously during the migration process without blocking the reading and writing of the entire table, which greatly improves the flexibility of data schema when adjusting the business logic. Coupled with the tuning of various global parameter variables provided by TiDB, we can flexibly adjust the execution speed of asynchronous tasks according to the current cluster traffic conditions. After the migration was completed, we started to rebuild the data query of the business side and consumer side applications. After sufficient tuning and testing, we gradually switched all the applications in the production environment to new applications for querying TiDB. Here comes some qualities that deeply impressed us during the using. First, TiDB support for diverse multi-dimensional real-time query is fairly reliable, which perfectly meets us core requirements of throughput and low latency for data of business side and customer side. Take the API service on business as an example. The common query time has dropped to the millisecond to tens of milliseconds, Such speed can keep on when the QPIs rises to 1,000. The using experience of our API service has been optimized a lot from that. The other is the column storage mode provided by TiDB. When running data analysis tasks, some of our queries is also fairly efficient. For example, when querying the duplicated content value of a field in a table with hundreds of millions of data, the results can often be available within a few seconds. Most importantly, TiDB's Smart SQL Optimizer can select the most cost-effective data query execution plan according to the data distribution and has multiple built-in ways to allow developers to flexibly adjust and optimize SQL execution plans. We think that is one of the most practical and powerful core functions of TiDB. In the process of using TiDB, we have some best practice to share. First is about SQL analysis and optimization. In the early stage of accessing TiDB, it is recommended to explain and analyze your every SQL as much as possible, acquiring a deeper understanding of query plan, selection, and operators of SQL execution. Then you need to avoid executing SQLs that occupy a large amount of memory. Otherwise, OOM may occur. We suggest that you should set global parameters to limit the maximum memory usage of a single SQL. Also, you can use create SQL plan binding and various SQL hint mechanisms for tuning. As mentioned earlier, you can customize your query patterns by flexibly adjusting SQL execution plans and operator tasks. In addition, regarding data writing, you should avoid writing hotspots. One of the solutions is to use auto-random instead of auto-increment for primary keys that do not require increasing trend to scatter write operations. Another is pre-split regimes when creating a table scheme which scatters write operations by pre-dividing data regions. The last is to combine the optimization at the application level. You need to avoid unnecessary red hotspots causing the disk I/O to be in a busy state. And we suggest you combine your table design and index design to adjust your data query mode. Use more suitable and efficient SQL for business queries. And at the same time, supplement with the necessary caching mechanism to speed up your queries. So that's all about what I want to share about TiDB. Thanks for your listening.